Now, let us discuss about detection of ultrasonic wave. As we all know that we have already covered what do we mean by ultrasonic wave, what are various categories of sound, whether it is infrasonic, audible or ultrasonic wave, and under which frequency if a sound lies, then it is termed as ultrasonic wave. All this has already been covered till now. So now it is time for us to determine how to detect ultrasonic wave, because it becomes very much important to detect or to know detection method of ultrasonic wave, because once we know various detection method of ultrasonic wave, then and then only we can easily use ultrasonic wave for various applications, right? We can use ultrasonic wave for determining depth of sea or for determining any cracks in any material or any bridges or any such things, right? So for that we first understand how we can detect the ultrasonic wave, right? So there are basically 4 different methods of detection for ultrasonic wave. Let us start with the first one. So the first method is quartz crystal method. We know that in piezoelectric method for generating ultrasonic wave, we have already used quartz crystal there, right? So again, for detection method also we are using quartz crystal method. In case of quartz crystal method, what we do is, it is based on the principle similar to that of piezoelectric effect, right? When one pair of opposite phase of quartz is exposed to ultrasonic wave, right? When we expose one phase of quartz material opposite to ultrasonic wave, in the other pair of opposite phase, charge will get developed, right? What we are doing is, now we are using 2 different quartz material, one for generating ultrasonic wave and one for detecting ultrasonic wave, right? So when one pair of opposite phase of quartz material is exposed to ultrasonic wave, then in other pair of opposite phase, charge will get developed and these charges are amplified, right? So whatsoever charge has been developed, it will then amplified and detected using suitable electronic circuit. So this is how we can detect it, right? Now, second method is thermal detection method. So what do we do in thermal detection method? When ultrasonic waves are propagated through a medium, we all know that ultrasonic wave is a sound wave, it needs material medium to travel, right? So when the ultrasonic wave are propagated through a medium, or when they are passed through any medium, the temperature of medium will be changed, right? Due to passage of ultrasonic wave, temperature will be changed, and due to alternate compression and rarefaction or refraction, right? Due to alternate compression and rarefaction, the temperature of that particular medium will be changing with respect to time. Now, in case of stationary wave, there is no change in temperature, right? So in case of stationary wave, there is a change in temperature at nodes and no change in temperature at antinodes, right? Temperature will be changed at nodes, but at antinode there will be no change in temperature. Based on this particular principle, by sensing the change in temperature using suitable component, we are detecting ultrasonic wave using thermal detection method. So what we are doing is, we are actually determining thermal capacity or temperature of the given medium, and by analyzing that temperature we are trying to determine the ultrasonic frequency, right? So this is the thermal detection method. Now the third method is sensitive flame method. So what do we mean by sensitive flame method? This is basically a qualitative method to detect ultrasonic wave. Now when a narrow sensitive flame, right, when we are using a narrow sensitive flame is moved in a medium of ultrasonic wave, the flame will remain steady at antinodes, but it will flicker. Flicker means it will either vibrate or it will decrease in the intensity, right? So it will remain constant at antinodes, but it will flicker at nodes due to maximum change in pressure, right? Due to the, since ultrasonic wave need material medium to propagate, when they propagate from medium, temperature of that medium changes, and as temperature changes, pressure will automatically change because temperature and pressure are associated with each other, right? So once they change temperature, pressure will be changed, and due to this change in pressure, when the flame will come in nearby nodes or at nodes, it will start flicking up due to change in pressure. Thus, by observing the behavior of flame, the presence of ultrasonic wave can be detected using this sensitive flame method. Now, the fourth and last method of detection of ultrasonic wave is Kunz tube method. Now, this is very important. In this method, we are using to determine low frequency ultrasonic wave, right? Whenever we are having any low frequency ultrasonic wave, Kunz tube method will be utilized. In this, we are having a Kunz tube apparatus. As you can see in this particular figure, this is a Kunz tube apparatus, right? Now it consists of a long glass tube, as you can see here, long glass tube which is around 1 meter in length and 5 centimeter in diameter, right? It will be 1 meter in length and 5 centimeter in diameter. It will kept horizontally with 2 supports. As you can see here, one support is this one and another one is this support. So with the help of these 2 supports, we are keeping it horizontal on a wooden base. This is a wooden base. This and this are 2 supports, right? And one end of the tube will be fitted with an adjustable piston rod, right? So here you can see we have fitted it with an adjustable piston rod. A quartz crystal will be placed in between 2 metal plates, right? So we will place a quartz crystal here in between these 2 metal plates. The glass tube will be thoroughly dried by passing through a hot blast air. A thin layer of dry lycopodium or coke powder is spread along the entire length of the glass tube. When stationary ultrasound wave generated using piezoelectric method, right, in the air contained in the long glass tube, the lycopodium powder gets collected in the form of heaps at the node and is then blown off the antinode. Thus, the formation of heap at the node confirms that the nature of transmitted sound wave is ultrasonic wave. So, we are using this powder, and once we get heaps of that powder collected at antinode, it shows that it is an ultrasonic wave which is passing through this medium, right? So this is Kunz method for determining the ultrasonic wave. Now let us talk about destructive and non-destructive test method. What is the basic difference between destructive and non-destructive test method? In case of destructive test method, measurements are very direct and it is reliable, right? the measurement remain direct and reliable, whereas in case of indirect method, there is a reliability has to be verified. We need to verify whether the results are being reliable or not. That means whether it is correct or not. In case of destructive method, tests are not made on object directly, whereas in case of non-destructive method, 100% tests are done directly on the object. Destructive method are time consuming, whereas non-destructive method are very quick and rapid. Usually quantitative measurement can be given by destructive method, whereas qualitative measurement are much more on the higher side when we talk about non-destructive method, but they can also generate quantitative measurement if required, right? In-service testing for destructive method is not possible, whereas in case of non-destructive test, in-service testing is also possible. Preparation of test specimen for destructive method is very costly, whereas there is only little preparation required for non-destructive test. So it becomes very important for us to know the basic difference between both the method of determination of ultrasonic wave, that is destructive method and non-destructive method, right? That is destructive test or non-destructive test. Now let us talk about application of ultrasonic wave. So when we talk about application of ultrasonic wave, first application which comes into mind is sonar. One of the major application of ultrasonic wave is sonar. So sonar is basically stand for sound navigation and ranging. Sonar, sound, SO here you can see SO stands for sound, NA stands for navigation, and AR stands for ranging, right? So sound, navigation and ranging. It is based on the principle of echo sounding. In this acoustical technique, high frequency ultrasonic waves are used, right? We use sonar technique for determination of depth of sea, depth of rock in the sea, or any other such applications. Next application is cavitation. In cavitation, high power and low frequency ultrasonic wave is used, right? Ultrasonic processor and cleaner. In a processor and cleaner, the principle of cavitation is used for ultrasonic cleaning, ultrasonic drilling and cutting, ultrasonic welding, soldering, etc. For all these applications, we use ultrasonic sound waves for either cleaning, cutting, welding, soldering, etc. Third application is based on various segments of our day-to-day life, such as to detect flaws or cracks in the metals. That metal may be a metal in your bridges, in your equipment, or anything, right? It is used to detect ships, submarines, icebergs, etc. in the oceans. It is also used for soldering, as we have just now discussed, or for welding some material, or for cutting. It acts just like a catalytic agent and accelerates the chemical reaction as well. Now, lastly, when we talk about application of ultrasonic wave in medical field, it is used to remove kidney stones and brain tumor without shedding any blood, right? This is very important. Next is, it is also used to remove broken teeth, or for sterilizing milk and for killing bacteria, we use ultrasonic wave. We also use ultrasonic wave to study blood flow velocity in blood vessels of our body, and to diagnose or to detect your tumors, cancers, etc. we use ultrasonic wave. So these are few very important applications of ultrasonic wave which we must remember.